rational function, while often taught as a purely mathematical concept, can also be used in real-life application like economics, astronomy, and architecture. For today, I'll use it to calculate how many calories per minute are burned using this model. So the model I'll be using is in the form of x equal 500 over x plus 2. And one of its characteristics is the domain and the range. To figure them out, we must first find out the vertical and the horizontal asymptote. To get the vertical asymptote, we must make the denominator equal to 0. First, we must identify the denominator. For my case, it is x plus 2. So we must both subtract both sides by 2. With that, we can determine that our vertical asymptote is equal to negative 2. As for horizontal asymptote, we can compare the degree of the numerator and the denominator. Since the degree of the numerator, 500, is 0 and the degree of the denominator, x plus 2, is 1, the horizontal asymptote is determined by the ratio of the coefficient as x approaches infinity and negative infinity. The value of the function approaches to 0, therefore the horizontal asymptote is equal to 0. Since we determined what our vertical and horizontal asymptote is, we can now figure what is the domain and the range of our function. The domain refers to all possible inputs value x for the function. In our case, the function becomes undefined when the denominator equals 0, which we find to occur at x equals negative 2. Therefore, the denominator is all real number except negative 2, expressed as x union of negative infinity to negative 2 and negative 2 to infinity. The range represents all possible output values y of the function. Since the horizontal asymptote is equal to 0, the function will never reach equal to 0 and y equals 0. Furthermore, because the numerator is positive, the output will always be positive for all valid x. Thus, the range is the union of negative infinity to 0, 0 to infinity. Now that we discussed the original function and its characteristics, let's move to finding its inverse and the domain and ranges it comes with. To find the inverse of a function, we switch the role of x and cx for my function, which is written as x equals 500 over x plus 2. We start replacing x with y, that this gives us y equals 500 over x plus 2. Next, to find the inverse, we switch x and y, so it becomes x equals 500 over y plus 2. From that, we solve for y. First, we multiply both sides by y plus 2 to get rid of the denominator, resulting in x times the quantity y plus 2 equals 500. Expanding this, we have x times y plus 2x equals 500. We then isolate by subtracting 2x from both sides, giving x times y equals 500 minus 2x. Finally, we divide everything by x to solve for y, resulting in y equals the quantity 500 minus 2x all over x. Now, we can figure out the domain and range of the inverse function. The domain of the inverse function is all real number except x equals 0. In interval notation, we can express the domain as y union of negative infinity to 0 and 0 to infinity, a positive infinity. Next, let's find out the range of the inverse function. The range of the inverse function corresponds to the domain of the original function. From earlier, we determined that the domain of the original function is all real number except x equals negative 2. So that the range of the inverse function is x union of negative infinity to negative 2 and negative 2 to positive infinity. To sum up all of this, we look at the rational function, its asymptote, domain, and ranges, as well as the domain and ranges of its inverse. That is now all I can report. Thank you.